So today we're trying to solve the equation, a ball is thrown vertically upward with an initial velocity of 27 meters per second. How long is the ball in the air? What is the greatest height reached by the ball? And where is the first time the ball is half of its initial velocity? So here is our diagram. We're going to put everything we know onto this diagram. So we have a ball is thrown vertically upward with an initial velocity of 27 meters per second. So the ball is thrown upwards, it reaches a peak, and it comes down. So we know the initial velocity is 27 meters per second, and the final velocity is negative 27 meters per second, because when the ball is traveling up, it's a positive number, and when it comes down, it's a negative number. At the peak, time is unknown, displacement is unknown, the initial velocity is 13.5 meters per second because it's half, and the final velocity is 0 meters per second. Some things to keep in mind. Our acceleration for this problem is always going to be negative 9.8 meters per second squared, because for a free fall equation, the force of gravity is negative 9.8 meters per second squared, and the force of gravity is equal to acceleration. Therefore, the acceleration will always equal negative 9.8 meters per second squared in this equation. More things to keep in mind. Displacement is a line from point A to point B. Velocity is speed in a specific direction. Acceleration is the rate of change of velocity, and acceleration is caused by a push or pull. There are going to be two main equations we are using to solve this equation. We have displacement equals initial velocity times time plus 1/2 acceleration times time squared, and acceleration equals final velocity minus initial velocity over time. So the first part of our problem is how long is the ball in the air for? So we are solving for time. However, the equation that we know and were taught in class is acceleration equals final velocity minus initial velocity over time. So we can rewrite that as time equals final velocity minus initial velocity over acceleration. Here are some numbers that we do know. Acceleration, again, is always going to be negative 9.8 meters per second squared, because that is the force of gravity in a free fall equation, and the force of gravity is equal to acceleration. The initial velocity is 27 meters per second, because it was given in the equation. The final velocity is negative 27 meters per second. Like mentioned before, when the ball is traveling back down, it's going down, so it's negative. And time is the unknown, which is what we are solving for. So now we can plug in what we know. Negative 27 meters per second minus 27 meters per second over negative 9.8 meters per second squared. This is what it would look like if you used unit analysis. You have your negative 27 meters per second minus 27 meters per second divided by negative 9.8 meters per second squared. This second crosses out with one of the seconds. This meter crosses out with that meter, leaving 1 second in the numerator, which means your unit is seconds, which you know is correct because you're solving for time, and time is measured in seconds. So after you do out all of your math, you get time equals 5.51 seconds. So now we have step 2. We're solving what is the greatest height reached by the ball. If we go back to our diagram, the greatest height reached by the ball is this peaked point at the top. That's our displacement. We know the displacement equation is initial velocity times time plus 1/2 acceleration times time squared. However, one thing we need to notice is when we plug in a number for time, it's 2.75, not 5.51, which is what we just found. The time 5.51 seconds is the time it took for the ball to start at the bottom, peak, and come back down. But because we are finding for the point at the top, we are using half of that number. So half of 5.51 is 2.75. So now we plug in what we know. We know that the initial velocity is 27 meters per second because it's what the equation gave us, times 2.75, which is half of the 5.51 we found for the whole time, plus 1/2 negative 9.8 meters per second squared. Remember, acceleration will always be this number for this kind of problem because in a free fall equation, the force of gravity equals acceleration, times 2.75 squared. This is what it would look like if you did unit analysis. You have your 27 meters per second times 2.75 seconds plus 1/2 of negative 9.8 meters per second squared times 2.75 times 2.75. The reason you do 2.75 twice is because you have to square it. This seconds cancels out with this seconds. This second squared cancels out with 1, 2 of the seconds. So now you're left with a meter, which you know is correct because you're solving for displacement, and displacement is always measured in meters. So after you multiply these two numbers and add it to this mathematical equation, you get 37.19 meters. So at 37.19 meters, that is the greatest height reached by the ball. So now that we found what is the greatest height reached by the ball and how long the ball is in the air, we can uncover the first tab. So now we know that the displacement at the peak is 37.19 meters and time is 2.75 seconds because it's half of the 5.51 seconds that we found. So for the last part of the equation, where is the first time the ball is half of its initial velocity, we're going to do the exact same steps just with different numbers. So step 3, we have to solve for time again so we can plug that into the displacement equation. So we have time equals final velocity minus initial velocity over acceleration. We know the final velocity is 0 meters per second. We know the initial velocity is 13.5 meters per second because we are trying to figure out the first time the ball is half of its initial velocity, and the initial velocity is 27 meters per second. So half of 27 is 13.5 meters per second. And the acceleration is negative 9.8 meters per second squared because that is the force of gravity, and in a free fall equation, the force of gravity is equal to acceleration. Just a little reminder of where I got these numbers. If we go back to our diagram, we know that at the top, the final velocity is 0 meters per second and the initial velocity is 13.5 meters per second. So plug in our numbers. We have 0 meters per second minus 13.5 meters per second over negative 9.8 meters per second squared. We do unit analysis just like before. 0 minus 13.5. And then you divide it by negative 9.8 meters per second squared. This second cancels out with that second. This meter cancels out with that meter, leaving 1 second in the numerator. Because the end unit is seconds, we know that it's correct because we are solving for time and time is measured in seconds. After you do 0 minus 13.5 divided by negative 9.8, you get time equals 1.378 seconds. So to find where the first time the ball is half of its initial velocity, we are solving for displacement. So we have the same equation that we learned in class and that we did in step 2, we're going to use in step 4. Displacement equals initial velocity times time plus 1/2 acceleration times squared. Because we're solving for half of its initial velocity, again we're going to use 13.5 meters per second. Then we just solve for time, which is 1.378 seconds, so you multiply those two numbers. Then you add 1/2 of negative 9.8 meters per second squared as your acceleration, and then 1.378 squared. So here's our unit analysis, just like step 2. You have 13.5 meters per second times 1.378 seconds, the seconds cancel out, plus 1/2 of negative 9.8 meters per second squared times 1.378 times 1.378. It's twice because it's squared. This second squared crosses out with 1 second and the other second, leaving with meters at the top. Because our end unit is meters, we know that we did the unit analysis correct because we're solving for displacement, and displacement always ends in meters. After you multiply the two and add this mathematical equation together, you get 9.298 meters. So now we can uncover the last tab. So now let's go back and make sure we answered everything of the equation. So we have a ball is thrown vertically upward with an initial velocity of 27 meters per second. How long is the ball in the air? We found that, 5.51 seconds. What is the greatest height reached by the ball? We found that again, 37.19 meters. And where is the first time the ball is half of its initial velocity? At 1.38 seconds, the ball is 9.298 meters. Here's our diagram all filled out. The unknowns are no longer unknown. We know the time is 2.75 seconds. We know the displacement at the peak is 37.19 meters. We know when the initial velocity is half of the original initial velocity, the time is 1.378 seconds, and the displacement is 9.298 meters. And we know at the bottom the final velocity is negative 27 meters per second because the ball is traveling downward, and the time is 5.51 seconds. And that is how you solve the equation of if a ball is thrown vertically upward with an initial velocity of 27 meters per second, we can find how long the ball is in the air, what is the greatest height reached by the ball, and where the first time the ball is half of its initial velocity. I hope this video was helpful.